Hello class, welcome back to our YouTube channel, and today our lesson is about the statistics and probability, and we are going to proceed to the lesson 5, which is the normal random variable. So we have already learned about the random variable and its classification from our previous modules. Now we are going to discuss the probability distribution, which is the normal probability distribution, or also known as the normal curve, which is used to determine the probabilities of a continuous random variable. So previously we had learned and discussed the discrete random variable. So this time we are going to focus on the continuous random variable, or the normal random variable. Let us have our objectives. So the learner will be able to illustrate the normal random variable and its characteristics, and understand how a normal curve used in our daily life through the application of empirical formula. So first, let us define what we mean by normal probability distribution. So it is a probability distribution of, again, the continuous random variables. It shows the graphical representation of the random variables obtained through measurement. So we already classified the two kinds of the random variables, which are discrete and continuous. And for the discrete, the discrete random variables are the random variables which can be counted, and while the continuous random variable were obtained through the use of measuring or measurement. So it shows this probability distribution shows or represent the random variables that were obtained through the measurement. And also an example are the height, the weight, the percentile, ranks, some test results, and or any data with infinite values. So this normal probability distribution were used to describe the characteristics of populations, and will be able to help us to visualize the inference we make about the population. So some characteristics and its parameters. It is also used to determine the probabilities and percentile of the continuous random variables. So that is the normal probability distribution. So how can we know if it's a normal probability distribution? We have the properties of the curve, the specific curve of the normal distribution, normal probability distribution. So we have 6. So the normal distribution are also known or popularly known as the normal curve. So we have here the properties. First, the normal curve is a bell shape. So are we familiar with the bell shape? So later on, I'll show you a specific curve that is a bell shape. Second property, the curve is symmetrical about its center. So this means that if we draw a segment from the peak of the curve down the horizontal axis, the segment divides the curve, the normal curve, into two parts. So that means that is the meaning of symmetrical. Third property, the mean, median, and mode coincide at the center. So I'll show you the graph. So this is an example of normal curve. So this shows a normal curve. This one is a bell shape. So this symmetric side, so when we divide the curve to two sides, so this should be symmetric. So this is the middle from the peak to the horizontal axis. So this is also what we call the mean. So this mean, median, and mode coincide at the center. So they're all here at the peak, at the center. That means this normal curve is a unimodal. The mean, median, mode are equal. Now, let's have the fourth property. The width of the curve is determined by the standard deviation of the distribution. So, in here, other than the mean, the standard deviation is necessary, is very important for us to properly illustrate the normal curve or the normal probability distribution. So here is our mean in the place on the center from the peak to the horizontal line. This is the value for our mean. And then we have to consider the multiples of the standard deviation. So we have 1 sigma, 2 sigma, 3 sigma to our right side. So this 6 multiples of the standard deviation will determine the width of the curve. So this from -3 sigma to +3 sigma. And the tails of the curve flatten out indefinitely along the horizontal axis, always approaching the x-axis or our horizontal line, but never touching it. So this means that our bell-shaped curve or the normal curve has an asymptotical tail. Thus, the tails are asymptotic. So these tails or the minimum sides of the curve are the asymptotic to the baseline. So this portion of the graph are asymptotic to a reference axis or another graph called an asymptote. So these are asymptotes. Then these are the two sides, two asymptotic tail. And last property of the normal curve, the area under the curve is 1. So the total area we have, or the probability, so this is the region which has an area, total area equals to 1, or the normal curve represents the probability or the proportion, or we can also call percentage, associated with specific set of measurement values. values. So this region are also the probability that is approximately 100. So we have area which is 100%, which is also equals to 1 in probability.